Good morning, good morning. We're going to wait about 2 more minutes to get started. Just waiting for a few more people to join. Hope y'all had a good weekend. It was cold on Saturday. It's supposed to be beautiful today. We're going to start in about 1 more minute. We are on week 5, day 1. Week 5, day 1. We're going to start promptly at 10. Good morning, good morning. Week 5, day 1. That's where we are. Week 5, day 1. Good morning, good morning. We're going to start in about 20 seconds, promptly at 10 o'clock. We're on week 5, day 1. Hope y'all had an amazing weekend. Good morning, you two. We're going to start promptly at 10. Oh, it is 10. It is 10. All right, so I'm going to start with a few announcements. First of all, your term 3 grades have been posted. Good morning, Sacred. Your term 3 grades have been posted in Aspen. You should be able to log in and see them. If you have any questions, please feel free, send me a message, send me an email, whatever works for you guys. Overall, I'm pretty impressed with you guys. Those of you guys that have been coming and joining the lives, you really improved your grade. Now, before we dive into our new material, I just want to remind you all, term 4 counts. You will be getting a grade for term 4. So I need you guys to make sure you're still doing your work, turning your work in so I can grade it, so I can look at it. Term 4 still counts, okay? So far, term 4 ends on May 29th. Okay, so we've actually been in term 4 for about 2 weeks now, and we have about 3 weeks left. The first full assignment that is going in for term 4 is your week 4 packet. So that's the packet we wrapped up last Wednesday. That completed packet is going to be your first full grade for term 4. Make sure you're sending those in. You can either take pictures, send those to me, or drop it off at the school, and I will pick it up and grade it. Also, please make sure you are attending the lives. You do get points for that as well. I will drop our attendance code in a little bit later. All right, so for our proper use of time, let's go ahead and get started. Like I said, we are on week 5, day 1. Today, we're going to learn about deviations from the mean, okay? So for those of you that need the reminder, mean is average. To find the average, we add up all of our values and then we divide by the number we have. Okay, so let's jump into our opening. It says, a consumer's organization is planning a study of the various brands of batteries that are available. As part of its planning, it measures lifetime, i.e., how long battery can be used before it must be replaced for each of 6 batteries of brand A and 8 batteries of brand B. Dot plots showing the battery lives for each brand are shown below. So this is brand A and this is brand B. If you don't have this page, just write it on a blank sheet of paper. I'll still accept that. Okay? So question number 1 says, approximate the value of each dot and calculate the mean battery life for brand A. So we are going to be working on this dot plot right here. It's telling us that we need to find the value for each of these dots and then find the mean or the average for those values. Okay? So I'm going to start at this dot, and it looks like this dot is around 83. So I'm going to say 83. I'm going to come to this dot, which looks to be around 94. This dot, which is around 96. This dot, which is about 106. This dot, which is about 113. And then this dot, which is about 114. Okay, so let me just make sure I have them all. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so now to find the mean, we need to add these all together. And I know I'm smart, but I'm not that smart, so I'm actually going to use a calculator to support me. All right, I'm going to put it up here for y'all to see. All right, so we're going to do 83 plus 94 plus 96 plus 106 plus 113 plus 114 is 606. Now, we're not done yet because we still have to, because we're finding the average, so we're going to have to divide by the number of data points we have, which is 1, 2, 3, 4, 5, 6. So I know 606 divided by 6 is 101. So our mean is 101. And that's only for brand A. Okay? So now question number 2 says, approximate the value of each dot and calculate the mean battery life of brand B. So we're going to do the same thing, except this time we're going to do our second dot plot, which is for brand B. Okay? So my first dot looks to be about 73. My second dot looks to be about 76. Let's say that's 92. It looks to be about 94. Then I have 110. And that's going to be about 113. Oh, I'm sorry, it's not 113. 15, 16, it's 117. This is supposed to be a 7. 117, 118, and then about 124. Okay? So, what I did is I approximated the value for each of these dots up here. I should have 8 values. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So now all I got to do is add them together. So let me start. I have 73 plus 76 plus 92 plus 94 plus 110 plus 117 plus 118 plus 124. And that gave me 804. So now we're not done because we have to divide by the total number of data points we have. And what I should see, 804, we're going to divide that by 8, and we get 100.5. Okay? So our mean data point, or our average data point for brand B, is 100.5. All right? So, question number 3 says, do the battery lives tend to differ more from battery to battery for brand A or from brand B? Okay, so what that's saying is, if we look at these 2 dot plots, which dot plot has more data points that are spread out? So which one has data points that are spread out more? So I want you to tell me, is it brand A or brand B? Drop it in the comments. Which one has data points that are more spread out? Drop it in the comments. Brand A or brand B? So brand A, brand B, that's spread out. We're looking for ones that are spread out more. I see somebody says brand A. I see Sacred says brand B. Anybody else want to chime in? Sacred, no, don't doubt yourself, because Sacred, you were actually right. It is brand B. So we're looking for ones that are spread out, guys, which means they cover more area on our dot plot. And when I look at brand A, they do look spread out, but they're still closer together than what we see in brand B. Brand B, they're spread out more over our dot plot. Okay? So what that means is, do the battery lives tend to differ more from battery A to brand B? So brand B has more variety. Sorry guys, I was thinking of the right word to use. In battery life. Because the data points are more spread out. Okay, so question number 4 says, why do you would you prefer battery brand that has battery lives that do not vary much from battery to battery? Why or why not? So what this is saying is, would you buy batteries where in one pack of batteries, one battery could last 4 hours, or one battery could last 7 hours, and then another battery could last 10 hours, and then another battery could last 3 hours? Or do you want to buy a pack of batteries where all the batteries last 10 hours, 11 hours, 10 hours, 11 hours? They all have a similar lifespan. So when we get to this question, you should prefer a brand with small variability because this means the batteries will have similar lifespans. Okay, so we finished our first page. Give me a thumbs up if you're ready to go on. Give me a thumbs down if you need me to go back to something. Thumbs up if you're good. Thumbs down if you need me to review something. I see 1 thumbs up. I need at least 1 more to move on. Thumbs up, we're good. Thumbs down, you have a question. I'm gonna give it a couple more seconds before we jump. Okay, there's my second thumbs up. All right, so let's keep going. So, the point of today's lesson is we're gonna look at data sets and we're gonna figure out how much a data point varies from our mean. So remember, our mean is our average, so we calculate the average for a set of data points. And now we're gonna calculate how far away data points lie from our mean. All right, so let's look at this table right here. Let me move it up a little bit. All right, this table is talking about brand A batteries, okay? And to help us out, they gave us our data values for brand A batteries. And then they also showed us that the mean was 101, which is great because that's what we calculated back here. So now what we're going to do is we are going to calculate how far away from the mean each of our data points are. And here's how you're going to do that. You're going to take your data point and then you're going to subtract the mean from it. So for our data point that was 83, we did 83 minus 101, which gave us a negative 18. Make sure you're doing the right signs, okay? So let's keep going. We're going to do our data point, which was 94, minus our mean, which was 101. And, whoops. When I use my calculator, guys, I see that it is negative 7. Okay? So now let's keep going. We're going to do 96 minus 101. Which gives me a negative 5. Then I'm going to do 106 minus 101, which gives me a positive 5. And then I'm going to do 113 minus 101, which gives me 12. And then our last data point, which is 114. 114 minus 101 gives me 13. Okay? So now, let me tell you a little bit about what this information tells us. If you have a negative deviation from the mean, so if your distance from the mean is negative, that means your value is less than our mean value. If you have a deviation from the mean or a distance from your mean value which is positive, that means that data point is higher than the mean. Okay? So, data point 83, our deviation from the mean, negative 18. I know it's below our mean. Data point 94, our deviation from the mean is negative 7. I know it's below the mean because it's a negative number. 96, our deviation from the mean is negative 5. I know it's below the mean. 106, our deviation from the mean is 5. So I know now I am above our mean average. 113, our deviation from the mean is 12, positive number, so I know it's greater than the mean, and so on. Okay? So now, let's look at brand B. First, it's asking us what did we find for our mean. So let's come back here and we see that our mean is 100.5. So we're just going to fill this in right here, 100.5. Now, remember, our deviation from the mean is data point minus the mean. Okay? So if I come down here, let's start our chart. I'm going to do 73 minus 100.5. And that is going to give me a negative 27.5. Then I'm going to do 76 minus 100.5. And that's going to give me a negative 24.5. Then I'm going to do 92 minus 100.5. Which is going to give me a negative 8.5. Then I'm going to do 94 minus 100.5, which gives me a negative 6.5. Then I'm going to do 110 minus 100.5. Which is going to give me 9.5. So what I should notice is all of these numbers are below my mean, and now I'm to the point where I'm above our mean. Okay? So now we're going to do 117 minus 100.5, which gives me 16.5. Now I'm going to do 118 minus 100.5, which is going to give me 17.5. And then I'm going to do 124 minus 100.5, which is going to give me 23.5. All right, so I'm going to pause, and I want you guys to give me a thumbs up if you understand how I calculated the deviation from the mean, or a thumbs down if you still have questions. Thumbs up if you understand what we just did in these two charts. Thumbs down if you need me to clarify something. Woo! I see my thumbs up rolling in. Good job, ladies. Woo! Yay! All right. So let me take a sip of water real quick. Okay. So our next question says, if you ignore the signs, so if you ignore our positive and negative signs, so if you ignore the signs of the values in the two tables above, which brand of battery has greater variability in its battery life? Okay? So what that's saying is, which brand has the highest deviations from the mean? Okay? So if I look up at brand A, the highest deviation I have is 18. Because remember, we're ignoring those positive and negative signs. So the highest deviation that brand A has is 18. So I'm just going to make a note Okay. So highest deviation, brand A, 18. Okay. So now I'm going to look at brand B. I have a 27.5, 24.5, 8.5, 6.5, 9.56. So my highest deviation for brand B is 27.5. So when I compare these two numbers, I see that it is brand B that has the higher variability. Okay? So let's keep going. Okay. Question number 3 says, the dot plot for both batteries is below. So we have brand A and brand B. Brand A, they put an X to represent the mean value. So they put an X. I'm going to draw it a little closer to the line so we can see it. To represent the mean value. So remember our mean was 101 for brand A. And then so they're telling us now we need to put an X for the mean value for brand B. Our brand B mean was 100.5, so it would go like right about here. And I'm just going to make a note that this is 100.5. Okay? So now it's saying, how could you determine the answer to question 2 by looking at the dot plots with the X's? So what this is saying is, if we had skipped all of this work, if we did not calculate the deviation of the mean for every data point, if we did not do that, how could we use what we see on this dot plot to answer which battery has the greater variation? Okay? And the simple answer to that is we would look at how far apart the dots are spread. And what we would see is that since brand B has our dots spread out way more than brand A does, that brand B has the greatest variation. Okay. All right. Let's keep going. We're doing good, guys. We're doing good. All right. So now we are on the section for the day that says your turn. Okay. So your turn says the lives of 5 batteries of a third brand, brand C, were determined. The dot plot below shows the lives of brand A and brand C batteries. Okay. Which brand has the greater mean battery life? Okay. So the first thing I want to do is I just want to check. Okay. So these data points are this for brand A are the same data points we've been working with. Okay. And because of that, I know the mean for brand A is 101. But now we have to be able to calculate the mean for brand C. Now, I know the question says you should be able to answer this question without doing any calculations, but we're going to do the calculations because I want to make sure we're practicing that. Okay? So, remember, mean is adding up all our data points, dividing by the total number of data points we have. So this looks to be about 97. So we're going to do 97 plus that looks to be about 106. That looks to be about 112, 115, and then 119. All right. Good morning, good morning. So let's do some math. 97 plus 106 plus 112 plus 115 plus 119 equals 549. And I had 1, 2, 3, 4, 5 data points, so we're going to divide that by 5. Not 2, 5. And then we see that the mean for brand C is going to be 109.8. Okay? So now let's go back to the question. Which brand has a greater mean battery life? Brand C. I'm going to put in parentheses that its mean is 109.8. Now, this question says we could have done this without doing the math, and they are correct. And what they mean by that is all of our data points for brand C are higher than most of the data points for brand A. So since brand C has data points that are a lot higher than brand A, that's how I can tell that it's going to have a higher mean. Okay? So, which brand shows greater variability? Okay? So what that means is when we look at our two lines, which brand has its dots spread out the most? Okay? So, when it comes to this question, which brand has it spread out the most, that's going to be brand A. Okay? So brand A shows greater variability. And I know that because when I come back up here, my dots are spread out more. Because remember, our mean for brand A is there, but our mean for brand C is here. And we can see that brand A, our dots are further away from our mean than for brand C. Okay? So the table below shows the lives for brand C batteries. Calculate the mean life for brand C. Which is 109.8. It wants us to include units, which is hours. So now, in order to calculate the deviation from the mean, remember, it is data point minus the mean. So it's going to be 115 minus, good morning, 109.8. Then it's going to be 119 minus 109.8. These boxes are really small. Then it's going to be 112 minus 109.8. Then it's going to be 98 minus 109.8. Then it's going to be 106 minus 109.8. Okay? So what we're going to do is we're now going to calculate the mean. We're actually going to do the math. But since these are really small, I'm actually going to write them down here for us to see, okay? So, let me, trying to get this in focus because it's a little out of focus. All right, there we go. All right. So, like I said, we're going to do the math from these up here, but since it's really scrunched together in our chart, I'm going to write them down here. All right, so we are going to do 115 minus 109.8, and we get 115 minus 109.8, which gives us 5.2. We're going to do 119 minus 109.8, which will equal 119 minus 109.8, which gives me 9.2. Then we're going to do 112 minus 109.8. Nope, 112 minus 109.8, which is going to give me 2.2. Then I'm going to do 98 minus 109.8. And that's a negative 11.8. So now remember, when I'm getting to the negative signs, I know that this data value is below our mean. And then finally, we have 106 minus 109.8. Minus 109.8, which gives me negative 3.8. All right. Okay. So what we just did is we calculated the deviation from the mean from all of our data points. Okay. So now what it says, write the deviations from the mean in the empty cells of the table for brand C. We've done that. We did that up there. Now it says, ignoring the signs, are the deviations from the mean generally larger for brand A or for brand C? Okay, so what we're going to do is we are going to come back to this chart we did right here. And we saw that our highest deviation from the mean for brand A was 18. And then we're going to come back to this, and we're going to see that our highest deviation. Now remember, to find our highest deviation, we're going to ignore our signs. So our highest deviation is 11.8. So brand A had a highest deviation of 18. Brand C has a highest deviation of 11.8. So when we come back to this question right here, it says, does your answer agree with your answer to exercise 3? Yep. I'm sorry, guys. They meant this 3. And our answer would be yes. So yes, our calculations agree that brand A has greater variability. All right. So before we move on to histograms, give me a thumbs up. Thumbs up that you understand what we just did with dot plots. Thumbs down if you still have questions. So before we move on to histograms, thumbs up that you understand what we just did with dot plots. Thumbs down if you still have questions. Sacred gave me a thumbs up. Kayla gave me a thumbs up. All right. And there's my third thumbs up. Woohoo! Okay. So, let's keep going. Good morning, good morning. So many new faces today. All right. So, now we're moving on to histograms. Now we're going to look at brand D and brand E. 100 batteries of brand D and 100 batteries of brand E were determined. The results are summarized in the histograms below. So here is our histogram for brand D, and here's our histogram for brand E. Okay? So here is our data plotted. So now let's look at our questions. Our question says, estimate the mean battery life for brand D. Do not do any calculations. Now this time we're not going to do the calculations. And the reason we're not going to do the calculations is because it's a little bit harder. So let's come back here. And what I should see is that this is the middle of my histogram. And since that's the middle of my histogram, that's going to be my mean. So we're going to say our mean for brand D is about 110. So looking at my histogram, this looks to be about my middle. So I'm going to say my mean for brand D is 110. Okay? Now it says, estimate the mean battery life for brand E. So we're going to do the same thing. We're going to come down here. It looks like the middle of my data is right here. So it looks like my mean is about 130 hours. Okay, so I'm just going to add units up here. So our mean for brand E, we said, was 130 hours. So how can you tell that brand D and brand E have similar variability in battery life? So remember, when we were talking about our dot plots, we said that variability was how spread out our data was. So now, if we come here and we look at our histograms, how can we tell that they have similar variability in battery life? And it's the same process. We can tell they have similar variability because when we look at how the data is spread out from our mean, it's still pretty similar. Okay? So, how can you tell that brand D and brand E have similar variability in battery life? Because the spread of data from the mean is similar for both batteries. All right. So here's where we are. This lesson actually went pretty quick. We have about 10 minutes left in our live. So what I'm going to do is I'm going to drop our attendance word in the comments so you guys know the attendance words you need to send in. And then we are going to move on and do our exit ticket together. Okay? So our attendance code word today will be flowers. Okay, so in order to get credit for attending today's live, make sure you send me the word flowers in a DM. Okay, so now that I've put that out there, let's go ahead and do our exit ticket. Okay, so using the axis below, draw a dot plot for these values. So here are our values right here. Let's go back and read the situation. My bad. 10 members of high school girls basketball team were asked how many hours, good morning, how many hours they studied in a typical week. Their responses are below. So we need to plot these points on our dot plot. So I have a 20, a 13, a 10, a 6, a 13, a 10, another 13, an 11, an 11, and a 10. All right, so we just made our dot plot. Now what we got to do is now it says calculate the mean study time for these students. Remember, to calculate mean, we're just going to add up all our data points and then divide by the number of data points we have. So let's do that right now. Got my calculator up. We're going to do 20 plus 13 plus 10 plus 6 plus 13 plus 10 plus 13 plus 11 plus 11 plus 10. Okay, so when I added up all my data points, I got 117. So now we're going to divide that by the number of data points we have. And we have 10 data points. So 117 divided by 10 equals, so 117 divided by 10 is 11.7. So that's our mean. Okay, so calculate the mean study time for the students. Our mean study time for the students is 11.7 hours. Okay, so now it says calculate the deviation from the mean for these study times and write the answers in the appropriate places on the table below. So now remember, to calculate deviation, it is data point minus the mean. So let's set them all up first and then we'll go back and do the math. So it's going to be, once again, these boxes are ridiculously small. So it's going to be 20 minus 11.7, 13 minus 11.7. Then we're going to do 10 minus 11.7, 6 minus 11.7, 13 minus 11.7, 10 minus 11.7, 13 minus 11.7, 11 minus 11.7, 11 minus 11.7, and 10 minus 11.7. Okay, so now we're going to do the math. Okay, what we're going to do is we're just going to simply solve what we wrote up here. So 20 minus 11.7 is 8.3. 13 minus 11.7 is 1.3. 10 minus 11.7 is a negative 1.7. 6 minus 11.7 is going to be 5.7, a negative 5.7. 13 minus 11.7 is going to be 1.3. 10 minus 11.7 is going to be a negative 1.7. 13 minus 11.7 is going to be 1.3. 11 minus 11.7 is going to be a negative 0.7. It's going to be the same thing right here. And then 10 minus 11.7 is going to be a negative 1.7. Okay. Woo, we're almost done, guys. We might finish this whole packet together today. Okay, so the study times for 14 girls from the soccer team at the same school as the one above are shown in the dot plot below. Boom. So based on the data, would the deviations from the mean be greater or less for the soccer players than for the basketball players? Okay, so I'm just going to let you think on that for a little bit. You don't have to type anything. But based on these deviations that we calculated, based on our distribution of data, which one do we think has the greatest variability? Okay, I'm going to give you, I just want you to think to yourself for a little bit. Okay, so the number line, okay, Kayla, so if we focused on the number lines, okay, so you're right, we can answer this question. Okay, so what we're going to do, all right, so what it's asking us is we have the basketball team, so this is our basketball team up here. And then down here is our soccer team. All right. And the question is asking us which one has the greatest deviation from the mean. Okay. And remember, greatest deviation from the mean also means the greatest variability in data. Okay? And so Kayla said the second number line or the soccer team. And you guys, Kayla, that is exactly correct. So the soccer team has greater variability. Greater variability and deviation from the mean. Kayla, do you know why? Can you type in why? I'm going to see if Kayla can tell me why. I'm going to give her a couple seconds to type in. She is correct. I just want to see if she can tell me why. Yes, Kayla, you are exactly correct. Because in the dot plot for the soccer team, the data points are more spread out. Excellent job, Kayla. Very good. Okay. So, we know the soccer team has greater variability and deviation from the mean because the dot plot for the second team, the data plots are more spread out. All right, guys, so the great news is we finished all of day 1 together. So we actually did amazing work today. So please do not forget to send me pictures of your completed pages so that you can get credit for them, okay? Those of you that joined us late, a little bit later today, I will be posting up pictures of our completed notes so that you can get what you missed. If you guys do not have any questions, we are done for the day. Please don't forget you can log into Aspen to see your Term 3 grade. Please don't forget Term 4 counts. If you want credit, I need to see the work you are doing. So you can either take pictures, send them to me in a DM, or just drop your completed packets off at the school because I do go and pick them up and grade them. On Wednesday, we will move on to day 2. So make sure you are checking my feed for any pre-work that we need to do for day 2. Okay? So guys, it's 10:46. You guys are good to go. I'll hang around a little bit in case anybody has questions. But if not, feel free to log off and I'll see you guys on Wednesday. All right, guys. Bye-bye. All right, I'm going to hang around for 30 more seconds. If there is no more questions, I'm going to log off. But I just want to give you guys about 30 more seconds in case you need some more time to type. All right, guys. I'll see you next time. Bye.